Hello and welcome to Introduction to Functions. Today we will be focusing on the key attributes of a parent function. This lesson will cover conceptual understanding of functions and their attributes as well as their characteristics. We'll also try to connect functions to everyday life or real life situations. Um, we also will talk about procedures of how to solve equations, formulas, and things of that sort that deals with the key attributes and characteristics of a parent function. We also will work on being able to declare or identify what a function is based off of its characteristics and traits or attributes. Meaning that we might be able to look at a table, a graph, or just even by the rules and understand what this particular graph function is. We'll also be covering subjects that you have had in the past as a refresher. Basically the things that you should already know. And we'll work on building skills on certain qualities or skills or traits that you'll need to know to be successful as far as understanding attributes to a function. We'll build on skills, and those are things that you really do need to know. And we'll practice the things that you have to do to be able to identify, recognize, represent, determine uh, attributes of a function. So let's get started. Okay, what should we know? A, we should know what a function is. Our prior knowledge should tell us that a function is assigned a single unique output for their for each of their inputs. Let's look at two tables to better understand. Functions using notation. Okay, let's dive straight into it. The set builder notation. When I first look at it, I swear I think I'm reading a foreign language, and after doing more research, it is a foreign language. So what does this mean? Each symbol has a meaning that can be interpreted. Take for instance the E. The E equals element, or it means element. The R, it stands for real numbers, and the line, it stands for such that. So let's pay attention to the set builder notation that is above elements. And if we look directly to the right of it, we can see how to say notation. The way that we would interpret this set builder notation, we would state it as all x that are elements of the set of real numbers such that the value of x is greater than 0. Also in this lesson, I want you to pay attention to the interval notation. Please do not forget from Algebra 1 that negative infinity goes negative and positive infinity goes positive. It runs forever. That's what infinity is. So when you see it, do not get overwhelmed. Let's keep everything pretty simple and just remember inverse of a function using notation. Alright, first of all, we got to think about it. We're not going to make it more difficult than what it is. The inverse of a function. A function that undoes the original function. So what does that mean? If we look right here at our diagram, we can see that all of our numbers on our right hand side traded places or interchanged with the numbers on the left hand side. So when we do inverse of a function on a table. Okay, first of all, I want to deal with a misconception. Before we start anything, I want to ask you, the inverse of a function, is it the opposite sign or is it the reciprocal of the original function? Keep that question in mind as we begin to look at this graph or this table. Okay, things we need to know. Recognize Need to know symmetry. Okay, we really do need to understand symmetry, so I'm gonna try to explain this the best I can. For instance, the human inverse of a function. Okay, let's see. Finding the symmetry. This is more about procedural. And for each of the following graphs, list any symmetries and state whether the graph is a function. The way that we can determine if a graph is a function, we will run a vertical line test on the function to see if it's a function, or we'll run a vertical line test on the graph to see if it's a function. Okay, let's start with graph A. Can you tell what graph A is? I'll give you a free moment to figure out the answer. Okay, the answer to graph A is, this graph is symmetric about its axis at the line x equals 3. There are no other symmetries. However, the graph passed the vertical line test, so it shows that it is a function. Now, let's move to graph F, and I will give you a free moment to see if you can figure out what graph F is. This graph of a cubic function, which you should have been able to identify offhand, is symmetric about the points -4 and -1, but not around the lines. This graph does show a function. Once again, we already could tell based off of it being a cubic function, and it also passes the vertical line test. Let's go to graph G. I'll give you a few more moments to answer this one. This graph parabola is lying on its side. Its symmetry is about the line of y equals 2. It is not a function because it does not pass the vertical line test. The vertical line touches the graph or the curve twice. Finding the symmetry. Now we're dealing with more procedural, but we still need to be able to also identify it from sight as well. For each of the following graphs, list any symmetry and state whether the graph is a function. Okay, let's look at graph A. Okay, the big discussion about graph A is determining if this is a function. Now, everyone should know what the vertical line test is. And we'll run a vertical line test on each and every last one of the graphs that we'll check today. Alright, so you looked at graph A. Is it a function? Does it have symmetry? Let's check. Let's run a vertical line test on it. Okay, before we even read anything else, we can tell that it is a function. Alright, graph A. This graph is symmetric about its axis. The line x is equal to 3. There is no other symmetry. The graph shows a function. We already stated that based off of our vertical line test. Okay, let's look at another graph. Let's look at graph F. Okay, right off the bat, we should be able to tell that this is a function before we even run a vertical line test because it looks exactly like a cubic function. Okay, let's run a vertical line test on it. And let's see, what is it? Graph F. This graph, of course, is a cubic function. It's symmetric about the point -4 and -1, but not around the line. This graph does show a function. Now, let's take a good look at graph G. Okay, we can tell that graph G is laying on its side. Let's run a vertical line test to see if it's a function. And we can tell that it's not a function because the vertical line is touching the graph or touching the curve two times. Okay, let's check and see what it is. Let's check our work. Graph G, this parabola is laying on its side. It is symmetric about the line y, which equals 2. It is not a function. Okay, great job. Now we're dealing with another attribute of a function, which is the asymptotic behavior. Asymptotic behavior is a behavior such that x approaches infinity if of x approaches the positive or negative infinity. Now it has two characteristics. One could be vertical, a vertical asymptote. Okay, now our job or our task is to find the domain of all asymptotes of the following function. Y equals x squared plus 3x plus 1 divided by 4x squared minus 2. The vertical asymptote is what we're going to look for first. And basically it comes from the zeros of the denominators. So I set the denominator equal to zeros inside. First of all, let's set it to 0. 4x squared minus 9 equals 0. The first step. Okay, now we're at the relative max and relative minimum. The relative maximum is the largest y-coordinate or value a function takes over a given interval or of the curve. One of the main things you need to remember is the max occurs when the parabola is open downwards. It will be at the very top of the curve when the parabola is open downwards. The relative minimum It's the smallest y-coordinate of the value. A function takes over a given interval of the curve. The minimum, the minimum occurs when the parabola opens upward. Once again, the minimum occurs when the parabola is open upward. And if we look at these two graphs below, we can tell that the max, we don't have one for this particular, for the quadratic, or excuse me, for the square root. We don't have a max, but we do have a minimum because it starts at the origin of 0, 0. Once again, for the absolute value, we do not have a max, but we have a min, because if we look at the lowest point, it starts at our origin 0, 0. Okay, now we're dealing with minimum and maximum. Relative maximum is the largest y-coordinate or value a function takes over a given interval of the curve. Now I want you to remember one thing. The the maximum of a curve occurs when the parabola is open downward. Relative minimum is the smallest y-coordinate or value a function takes over a given interval of the curve. The minimum occurs when the parabola opens upwards. If we notice at the absolute value function or the absolute function, we have a max. We have no max because the curve is open upward, but we have a min at 0. And if we also notice the quadratic, excuse me, the square root, our min, we have a min, but we do not have a max. Okay, what does absolute maximum mean? It means the highest point on the entire domain. If we look at the illustration, if we look at the illustration to the right, we can see by the arrow that it is at the very top of the parabola. Absolute minimum. Okay, we came to the end of
Okay,
part
we
one of
came to
our
the end
video.
of part one of our video.
Alright, now I need you to go ahead and
Alright,
complete
now
the
I need you to
quiz
go ahead
questions
and
in the
complete
study
the
guide.
quiz questions in the study
Also,
guide.
complete part two
Also,
of the video,
complete part two of
things
the
that
video,
you have to
things
do
that
at the end of
you have
class
to
or
do
for
at the
homework.
end of class or for
Do not
homework.
forget that you have
Do not
questions in
forget
your
that you
study
have
guide that goes
questions
with
in your
part
study
two,
guide that goes with part
dealing
two,
with your math model questions.
dealing with your math
We're
model
trying to
questions.
relate,
We're
we're
trying to
trying our
relate.
best to relate
We're trying
functions
our
to
best
real
to
life.
relate functions to
I'll
real
see you
life.
at the beginning of part two.
I'll see you at the
Be
beginning of
ready.
part two. Be ready. Okay, we finally made it to a break. Alright, what I'm going to ask is that we pause the video to let students answer all of the quiz questions that are in their study guides regarding the vocabulary of parent functions if they have not done so already. Then we will resume the video. Okay, now we're ready to start up. Things you have to do. You have to be able to recognize, determine, represent, and analyze
Okay,
attributes
now we're
of
entering
parent
into the
functions,
phase where we're going to really start getting hands on
such as the
and
absolute
practicing a lot
function,
of the things that
cubic
we have just
function,
learned. We will
reciprocal
be
or
recognizing,
rational
determining,
function,
representing, and
cube
analyzing
root
attributes
function,
of parent
as well
functions
as the
such
square
as
root
the
function.
absolute value or the absolute function, cubic function, reciprocal function, cube root function, square root function. Now I ask that we pause the video for a few minutes and let the students catch up on their study guide, answering all of the questions that are in their quiz, dealing with the vocabulary up until this point, and prepare yourselves with the study sheets that we have set for the next slides coming available. Okay, we finally made it to a break. Alright, what I'm going to ask is that we pause the video to let students answer all of the quiz questions that are in their study guides regarding the vocabulary of parent functions if they have not done so already. Then we will resume the video. Okay, now we're ready to start up. Things you have to do. You have to be able to recognize, determine, represent, and analyze attributes of parent functions, such as the absolute function, cubic function, reciprocal or rational function, cube root function, as well as the square root function. tribute group function. The absolute function. What is the rule for absolute function? Does the absolute function have symmetry? Math Models Application. A financial service company offers savings vehicles, such as CDs, to its clients. CDA has an amount of 2000, a term of 1 year, and an annual interest rate of 5% paid annually. Okay, I know you're wondering why, Mr. Spencer, are we doing this? This look like finance or it look like compound interest. Well, honestly, it's present value. And what we're going to do is we're going to answer this question, we're going to solve this question using the present value formula. And then we're going to try to write a function and be able to solve this same. Okay, we are still on the financial problem. And I hope that you did your brainstorming and that you got all of your functions and everything that you need in your head and on your paper. Alright, let's read it again. And let's kind of plug in the formula again so we'll know what we're working with. A financial service company offers savings vehicles such as CDs to its clients. CDA has an amount of 2000, a term of 1 year, and an annual interest rate of 5%. I want you to write this equation as a function. Now remember, we were looking for the future value. Future value equals present value times 1 plus the rate to the power of n. Okay? And I will also put your values up for you as well. 2000 times 1.5 to the power of 1. Okay, so how would we write this as a function? This is a great discussion. I'm going to give you a 3 seconds to pause. Think about how would you set it up as a function. And when I come back, I'll show you what I came up with. Okay, let's go. F of x would equal PV, and g of x would equal 1 plus r to the power of n. Now, I can use the exponential, however, I have a power to 1, and a power to 1 would not affect my parentheses, so I can still do it as a linear equation. Okay, so I'm going to set it up as f times g, which equals f times g of x. Now the way we would set this problem up is we would substitute x with g of x, and our problem would read more of f equals f times 1 plus